So today we're going to talk about linear and quadratic functions. A couple of things we're going to look at. Some of this should be review, just bringing it into the pre-calc kind of context. So the average rate of change, we've seen average rate of change before. This may be a new type of notation. We will be using this as the year progresses, but it's trying to tell you the change in y over change in x. And when you're looking at a constant rate of change, we can say a constant rate of change, a function defined on all real numbers, is a linear function if it has a constant non-zero average rate of change. So all of this rate of change stuff, change in y over change in x, this should hopefully be sounding like slope. So your rate of change, constant rate of change would be like the slope of an equation of a line. Okay, so with equations of lines, not only do we have slope, but then we also had the initial value. The initial value of a function is that constant term, which represents the value of the function when the input is 0. So that's key to keep in mind. So that initial value, or when that input is 0, is known as our y-intercept. That's where it starts to cross the y-axis. That's typically where you would start to plot that equation. So different ways we could look at this. Here are two just basic equations of lines below. So we're going to analyze the function by determining the rate of change and the initial value. So your rate of change, that's your slope. If we looked at this function, we could say your rate of change is 2/3. Your initial value, where your function starts, your y-intercept. If I made x 0, your initial value would be -5. So there's a whole bunch of different ways we could look at that. Okay, same thing over here for letter B. Your rate of change, that's your slope. So I can look here and say rate of change is -6. That initial value, again, that whole idea of your starting point. So if we had to do it algebraically, you could see plug in 0 for x, and you'd be able to find your y-intercept is 8. So I can say your initial value here is 8. Okay, what if we had to write an equation for a linear function? And so now they're going to give this in a function notation. So first thing we want to think is if we're writing an equation, we need slope. If we need slope, we have to be able to interpret what these, what the function notation is saying. So this is saying when x is -1, I plug it into the function, I get out a 2. When x is +3, I plug it into the function, and I get out a -2. So that's going to give us our coordinates. There we can plug it in and do our rate of change, change in y over change in x. So if we did change in y over change in x and simplified, so this would get us a -4 on top, a +4 on the bottom. Always reduce your slopes to simplest forms, and I can say our slope is a -1. So now we have to write the equation for the line. So we have points, we have a slope. I would think let's use our point-slope formula. And it doesn't matter which coordinate you take. So you could actually have a couple of different answers here. So let's say we took our first equation and we plugged in this first point. So we could have y -2 equals -1 times x minus a -1. Okay, that's one option. We could also do the same thing for this other coordinate. And I could have y minus a -2 equals my slope of -1, x minus 3. Now you could also solve and get y by itself, put it into mx plus b form if you wanted to, but there's no need. It just says write an equation, and both of those are equations of lines. Okay. Another way to ask average rate of change, so it's saying find the average rate of change for this function over the given interval. So when you see over the given interval, when you're looking at this, this is like saying our x values. So I have x values ranging from 1 to 3. So if I want to find the rate of change over that interval, now notice again, something different from up above, this is not an equation of a line. So I'm going to be finding a rate of change slightly different from slope in the fact that it's not constant. It's not a constant rate of change. It will be changing all over the parabola. It'll be one value for the interval 1 to 3. It would be a different value if we took a different interval. So First thing we have to do is actually evaluate the function at 1, so I can figure out what's going to happen when x is 1. So if we substitute a 1 in anywhere you see an x, you're going to make it 1 and simplify. Okay, this is going to simplify down, so when x is 1, we're going to get y is 5. So like we did up above, I could turn that into a coordinate. All right, now we're going to do the same thing. So we just want like your extremes. If it's going in an interval of 1 to 3, you want to test out 1 and test out 3. So we're going to evaluate the function for when x is 3. So plug in anywhere you see an x, make it a 3. And when you simplify this, you're going to get 23. So again, now this is going to get you a coordinate 3, 23. So if they want the average rate of change over that interval, now is where we're going to find the slope. And again, change in y over change in x. So if we simplify this down, this will get us 18 on our numerator over 2 in our denominator. Simplest forms gets us a slope of 9. Okay, so on our next page, we have a couple of different parabolas. So now we're going more into that quadratic function idea. Our graph on the left, this is our parent function. This is just our y equals x squared. So this is our original. Nothing's really happened to the function. Okay. Looking at the second graph, if we just talk transformations, maybe doing a quick little review on this, we can pick up a couple of different transformations. The negative is telling us a reflection over the x-axis. And that plus 3 is showing us we're going up 3. And I skipped over the 1/2, but that 1/2 is a vertical shrink. So it's going to that entire function, so I can say it's going to be a vertical motion. Things to take a look at. If we're looking at the quadratic and noticing a couple of important values, right here, this value, that's going to be at our coordinate 0, 3. That is our vertex or our turning point. I can also look at that and I can tell you that that's a maximum point if we're thinking a little review here. It's a maximum point at 3 when your x-coordinate is equal to 0. The other thing we can find is something called your axis of symmetry. And if I look, that axis of symmetry is happening right on our y-axis, which is our equation x equals 0. And you're going to notice it's also going through that point that we just had, that maximum point. Other things to take note of, it has a negative coefficient. We have that negative 1/2, and notice it's turning down, opening down. If I take a look at the one on the right-hand side, our red graph over here, I can notice that it is actually opening upwards. I have it 3 times, so that's a positive 3 there. So again, transformations, I can say that positive 3, that's a vertical stretch by 3. The plus 2 within our parentheses, that is going to be a shift to the left, 2. And then our negative 1 would tell us we would be going down 1. Now, if we looked at the 2 key things that we talked about from this last graph, our maximum point and our axis of symmetry, well, we don't have a maximum this time. We do have a minimum value. And I can see I have a minimum at negative 1 when x is negative 2. And our axis of symmetry, last time we said it went through that point, and again, it's going to go right through that point. So we can say our axis of symmetry is going to be at x equals negative 2 as well. So to kind of summarize some of this, we can see the graph, when a is greater than 0, when a is positive, it opens upwards. When a is negative or less than 0, it opens down. I always think down like a frown, it's sad, it's negative. Your axis of symmetry. So we can do this a couple of ways. One formula we're going to take a look at is x equals negative b over 2a. We're going to look at that next. Or like we had said up above, it's going to be the equation x equals, and then it's going to be the x coordinate of whatever you have, max, min. Okay. The point on the parabola that intersects its vertex, intersects its axis is the vertex. And that is always going to be its maximum or its minimum. So the vertex is the max or the vertex is the min. Okay, so for number 4, it says identify the vertex and the axis of symmetry of this problem. And then we have to figure out, will it have a maximum or a minimum, and where is it located? So we had an equation up above. We said x equals negative b over 2a. So looking at this, I can see a is negative 1, b is positive 6, c is negative 6. So if I wanted to find our axis of symmetry, I could just say it would be our b value of negative 6 over, and then I need 2 times my a value of negative 1. So if we simplify, we have a negative 6 over negative 2. That means our axis of symmetry is at a negative 3. Okay. Now we have to find the vertex. Well, we said before, if I knew where the axis was going to go through the vertex, and it would have that same x coordinate. So if I want to find the vertex, I should be able to evaluate that function at 3, and that would give me my y coordinate that I would need for my vertex. So if we simplify this down, this tells us y equals 3. So where's my vertex located? Well, at negative 3 from the x coordinate, and should be 3. And actually, I have a mistake here. That should be a positive 3. We were right the first time. And over here, this should be a positive 3. Okay. And then the last thing we have to figure out is, will it have a maximum or a minimum, and where is it located? Well, this is going to have a maximum. The reason we know it has a maximum is because our a value is less than 1. It is negative. So that means my graph would be opening down. It's negative, it turns down like a frown. So it has a maximum, and your maximum is located at the vertex. So the vertex is at 3, 3. Your maximum is at 3, 3. Now lastly, you could have a different form of this quadratic equation. This is called vertex form. And you can see our vertex form. Here's our formula. Looks a little different. And we will get some formulas for this. So the vertex is going to be the coordinates h comma k. Similar to, if you remember your equation of a circle, we had coordinates that were h comma k. And the axis is going to always be whatever h is. It's going to be x equals h. How do we find h? Well, h, just like we said before, is negative b over 2a. That's that axis of symmetry equation. And the k value comes from the formula c minus ah squared. In class, we will go over how this formula was developed. If a is greater than 0, like we said before, it's going to open up. And if it's less than 0, it's going to open down. So that part's not changing. That's going to stay constant. Okay, so taking a look at number 5 then, applying that information, we are going to use the vertex form of a quadratic function to find the vertex on the axis. We have to put this function into vertex form. So in order to get it into vertex form, we need the h value, we need the k value. We already know a. A is negative 1. We could find our other terms as well. B is negative 10, C is negative 26. In order to write this in vertex form, I need to know what h is. So h, we had the formula negative b over 2a. And if we simplify this down, we're going to find h is 5. Okay, now we also needed the k value. And k, we said, was c minus AH squared. And the only thing, you have to be careful with orders of operations on this. You have to square the h first before you do anything else. So if we plug this in, I have a negative 26 minus a negative 1 times 5 squared. So you do have to square the 5 first. Okay, so 5 squared, we get 25. 25 times negative 1 is a negative 25. So now I have a negative 26 minus a negative 25. That's going to leave me with k equaling negative 1. So if we now write this in that vertex form, we have our a value. A is negative 1 times x minus h squared plus our k value. Now notice our k value is negative 1. So plus a negative 1, we don't have to write that. We could just write minus 1. Okay, so from here, your vertex we set up above was h comma k. Well, I have h is 5, k is negative 1. There's our vertex. Our axis, that's going to be x equals whatever the h value is. So x equals 5, and there's our axis. So here's your vertex form. We know what the vertex is. We have our axis. Hope you like this. Like and subscribe. Have a good one.